Hello everyone, welcome to the channel. In this video, we will see a problem on work done by spring force by using work energy principle. In the previous video, we saw how to derive work done by spring force. So in this video, we will solve a problem on that concept. So the problem states that a block of mass 10 kg slides freely on a smooth vertical rod as shown in the figure. The mass is released from rest at a distance of 500 mm from the top of the spring. The spring constant is 60 Newton per mm. So they have given the stiffness of the spring, it is 60 Newton per mm. Determine the velocity. Determine the velocity of the block when the spring is compressed through 20 mm. The free length of the spring is 400 mm. Okay. So here they have given all the data. If you see, so this is our initial position, first position. So after it's been released, the block has come to this point. Okay, after coming to this point, the spring has been compressed through how many mm? It has been compressed to 20 mm. Okay, so that means this is our second position. So at first position, the velocity v1 is equal to 0 and x1 is nothing but the spring. Initially the spring is in deformed, so it will become 0. In the second position, v2 we have to find out, and x2 is nothing but the deformed spring. It has been 20 mm. Okay, so if you see the problem here, we have two things. One is block. The first one is block. Second one is we have a spring. So here the work done by the system will be work done by the block plus work done by the spring. Okay, so we'll be using these two concepts to find out the velocity. Fine. So given data, initial condition at position 1, v1 equal to 0 and x1 is nothing but the spring. Okay, so x1 is initially deformed. It's a deformed spring, so initially the spring isn't deformed. Okay, it didn't deformed it. Now at position 2, that means the block has been released from the top and the spring has deformed. So we have to find the velocity. v2 will become question mark and x2 will become 20 mm. Okay, now you have to note down one thing. In spring work done by spring force problem, you have to keep the stiffness of the spring in meter, Newton per meter. So I'm going to convert this 20 mm to meter as well. That will become 0.02 meter. Okay, so everything will be in the meter in the work done by spring problem. Fine. So the stiffness K equal to 60 Newton per mm. They have given mm, so we are going to convert into Newton per meter. So 60 divided by 10 power minus 3, because we are going to convert into Newton meter. So this will become, if we go upside, 60 into 10 power 3 Newton per meter. So this is stiffness of the spring as well. Okay, now so we know the v1 x1 v2 x2 and we got the stiffness as well. Okay, by work energy principle, we have work done equal to change in kinetic energy. So here, as I mentioned you earlier, here we have two things. One is work done by block plus work done by spring force. This is equal to change in kinetic energy, because this overall systems combines the work done. Okay, now we have to look for work done by the block first. Okay, first block, for work done by block will be force into distance plus work done by the spring force is half into k into x1 square minus x2 square equal to change in kinetic energy, it is half into m into v2 square minus v1 square. Okay, so here we have to look for the force for the block. So here we have only one force, that is the mass. The weight of the block is acting downward. The weight of the block is acting downward, that is 10 into 9.81. This is the force. And distance, we have to check for the distance. Now if you see distance between the spring and the block is 500, but once we release the block, because of the weight of the block, the spring has compressed to some 0.02 meter. So we have to add this 500. So 500 means it will become 0.5 meter plus 0.02 meter as well. That will become the total distance by the block. Okay, so force will be 10 into 9.81. So distance will be 0.5 meter plus 0.02 meter. This is the distance for the work done by the block, plus half into stiffness is equal to 60 into 10 power 3. So x1 initially it is deformed, so 0 minus x2 is 0.02 the whole square. This will be equal to half into mass is 10 kg into v2 we have to find out, minus v1 is 0. Okay, so if you do the calculation, we will get the v2. Okay, so now I solve one by one. So 10 into 9.81 into 0.5 plus 0.02. So this value will be 51.012 plus half into 60 10 power 3 into 0 minus 0.02 the whole square. This is minus 12. This is equal to, this is will come 5. So 5 v2 square. So 51.012 minus 12 something 5 v2 square will get us 39.012. So v2 square will be equal to 39.012 divided by 5. This gives me 7.8024. v2 square is 7. We have to find v2. What is the velocity? v2 will be equal to root of 7.8024. So this gives me the velocity 2.793 meter per second. So the velocity of the block when the spring is compressed is 2.793. Okay, 2.793. I hope you understood this problem. If you have any doubt, you can put it in the chat section or comment section. Thank you for watching.